a common ancestor, last common ancestor, only about 55 million years ago. That's not that long ago. They both swim before walking. Obviously, the whales never walk, but the hippos do swim before walking. They nurse their young underwater. Their testicles remain inside the body, like in the case of the whales. They are hairless, like in the case of whales, because they're not very useful underwater. And they don't sweat, again, for the same reason. It's not very useful to sweat underwater, so they don't have glands to sweat. The third point that I wanted to make was that evolution is not a theory of the origin of life. The origin of life is sometimes caricatured as this thing over here. This is the primordial soup. That's my version of the primordial soup. The idea that there was this kind of broth of complex organic compounds that somehow gave origin to life on Earth. That may or may not have been the case. There are several alternative theories on the origin of life, but my point that I want to make tonight is that evolution has nothing to do with the origin of life. The reason for that is because evolution requires what is called heritable variation for natural selection to act. Before there were living organisms, by definition, there was no heritable variation. There was no genetic variation of these organisms because organisms were not there to begin with. So the transition between the non-living and the living, it's not really a matter of evolutionary biology at all. It is a matter of physical chemistry, or at the interface between physical chemistry and biology. In fact, most of the people that work on the origin of life, and it is a very active field of research, there are several people that are interested in it. Most of those people are actually biophysicists or chemists, not biologists, for the good reason that there is nothing really that an evolutionary biologist can say one way or the other about the origin of life. It's just a different problem. Now, that doesn't mean that the origin of life is not a scientific problem. Of course it is. It's a pretty tough problem because it's something that happened probably only once and probably a long time ago. So, and of course, there's very little or nothing in the fossil record that can help us to figure it out. So it is a very tough problem. But there are different ways of approaching it. Certainly not going to give you the answer tonight. For one thing, it's because nobody knows the answer. For the other thing, is because it will require a separate lecture just on that. But one of the clues is coming from these kind of pictures and this kind of theory. There's a theory in a branch of mathematics now that's called complexity theory, which deals with the emergence of complex systems. And one of the things that this complexity theory explains is the emergence of these complex systems. You can't see much because this is a satellite picture taken at very low resolution, but those things that you're looking at there are convective cells that form spontaneously in the upper atmosphere. There is no way to explain these complex natural phenomena unless you allow for what's called the emergent property of the interaction of the molecules that make up these cells. Well, complexity theory explains how these things originate, and complexity theory is currently our best choice, or best bet to explain the emergence of another complex system, which is life on Earth. So people are working on it. I might get back to you on that in a few minutes. The fourth point that I wanted to make was that evolution is not a theory about the origin of the universe. The universe evolved, or you hear that the universe has evolved or is evolving, but it evolves only in a very general sense, in the sense of change through time. Well, change through time is not what evolutionary biologists consider evolution. There is no selection and no mutation. There's no mutations, no process equivalent to mutation in the formation of universes. And there is no natural selection that we know of, at least, in the origin of universes. So those are really literally apples and oranges. Now, we do know something about the origin of the universe. Again, this is some of the empirical evidence. This is a beautiful picture from the Hubble Space Telescope of these things which are called proto-galaxies. These are the building blocks of galaxies. These are very far away, and they existed a long time ago. The only reason we can see them now is because light takes several hundred millions of years to come back to us from them. So we actually can peek at what was happening directly by telescopic observation, what was happening a few millions of years or tens of millions of years after the origin of the universe. There's also an interesting set of theoretical research that actually addresses the origin of the universe. There are two major branches of modern physics that are trying to explain this kind of phenomenon. One is the general theory of relativity proposed by Einstein at the beginning of the century. And the other one is quantum mechanics, that Einstein actually never could quite accept because it just didn't fit his view of the world, and which was developed, ironically, based on Einstein's own research. Well, these two pieces of information are actually coming together in the 21st century in what physicists are now calling superstrings theory. Superstrings theory is, among other things, is one of our best bets to explain how the universe originated and why the universe that we live in is the way we observe it. I can give you plenty of references if you want to learn about superstrings theory. It's an extremely complicated branch of mathematics, but it is a fascinating enterprise. Now, after I told you all of this, and I told you, well, evolution is not about this, and it's not about that, well, does that mean that evolution failed if it cannot answer what creation is called the origin question? So if evolutionists cannot tell you how life originated or how the universe originated, isn't that a failure of evolutionary biology? From what I told you so far, you should have realized that that's not the case, because that literally is talking apple and oranges. Okay. Or if you want to use a different metaphor, it's like understanding a baseball game applying the rules of basketball. It just doesn't work that way. It's like asking theoretical physicists to explain evolutionary biology. Well, theoretical physicists wouldn't know where to begin with, because evolutionary biology has very little to do with quantum mechanics. So these are valid scientific questions, but they cannot be held against evolutionary biology. So, well, you haven't explained the origin of life, therefore, what are you talking about? It just doesn't work that way. The last point that I want to make before concluding the opening statement is to address the question of, well, does the variety of life on Earth require intelligent design? Which is, of course, why most people that are here tonight are interested in. And intelligent design, of course, can be a variety of things. Creationists don't necessarily agree on what intelligent design is to begin with. Some of them think of certain kind of God. Some of them actually think of, believe it or not, very smart extraterrestrials, a la Star Trek. But the question is, there are logical objections to the applications of intelligent design theory to the explanation of life on Earth. One is that it violates what is called Occam's razor. Occam's razor, which was proposed by William of Ockham in the 13th century, is actually the idea that you should avoid unnecessary hypotheses in order to explain something. What is an unnecessary hypothesis? Well, for example, I can explain why you're looking at this presentation based on the laws of physics. Based on what little I know about physics, I can tell you that there are some electrons that are coming here from my computer and they go down here, falling all the way up there, back to the projector, and the projector generates an image that is projected. I can explain both with optics and subatomic physics what's happening. I could also say, on top of that, there is a tiny little green monster which is actually taking these images from here and bringing them directly up there. That's possible. You would have to ask me, first of all, if it is invisible, how do you know that it's green, for one thing? But do I need that kind of explanation? No, I don't. That doesn't mean that there is no little green monster bringing my little electrons all the way to the image. It just is that I don't need that explanation. And it's not a good scientific theory. The reason for that is because you can come up with an infinite number of alternative stories that would all be equally unfalsifiable. There would be no way to test if they're right or not. And it would be all equally redundant. That's what Occam's razor does, and that's what creationism does with evolution. The second thing that creationism does with respect to evolution is it violates something that is sometimes called Hume's dictum. Hume didn't say it exactly along these lines, I'm paraphrasing here, but essentially said that when you want me to believe about extraordinary claims, you have to provide extraordinary evidence. The more extraordinary the claim is, the more extraordinary the evidence has to be. Let me give you another